Welcome to the class of Microwave and Radar Engineering. This is lecture number 2 and here we will discuss about the transmission line. So first we will discuss about the introduction to transmission line. As we know that the conventional two conductor transmission line, which is having a current flowing of very low frequency, clear, and this transmission line is used mainly for the transmission of any signal. Transmission line is a line which is transmitting the signal from one point to the another point. So conventional two conductor transmission line are commonly used for transmitting the microwave signal. Okay. Now if I want to use this transmission line to its full efficiency, then this line should be properly matched with its characteristic impedance. That means the impedance of the line should be matched with the characteristic impedance, or it should be matched with the impedance of the load. That means if a line is properly matched to its characteristic impedance at each terminal, its efficiency will reaches to its maximum. Clear? Now see, in ordinary circuit theory, means if I want to say that when the input signal having a frequency is very low, in ordinary circuit theory all impedance elements are lumped constant, because at that time the input signal frequency is low, that is around 50 hertz. Clear? Now in microwave signal, as we know that in microwave signal frequency operation is so high that the inductance of short length of conductor and capacitance between the conductor and their surroundings cannot be neglected. Means if I say that input signal frequency is high, then I cannot neglect the inductance and capacitance. Inductance capacitance role in transmission line cannot be neglected. This can be neglected when the input signal is very low. Clear? So that's why these inductance and capacitance should play an important role in the analysis of transmission line. That's why these inductance and capacitance are distributed along the length of the conductor. Means if I say this is a transmission line, these inductors and capacitance, they are distributed along the length of the conductor. Now see why the inductance and capacitance are distributed along the length of the conductor. You will see that, and we are using the distributed parameters. Clear? Now see, as we know that input signal is having a frequency, input signal frequency is high, so it means that the wavelength will be less. And for the microwave signal, when the input signal, if I say the range of microwave signal that is ranges from 1 gigahertz to 30 gigahertz or 300 gigahertz, the input signal frequency is high, then at that time wavelength is very less, or in the range of centimeters. Clear? So the wavelength is very short in comparison to the physical length of the line. Wavelength is short because if I say this is a transmission line having a length, means this one, if I say this one is positive, negative, clear? Now see, this having a length, let's say physical length of this transmission line is L, clear, and the input signal having a frequency is very high, so its wavelength will be in the range of centimeters. So the length of physical length of the transmission line is very high. So when this wave is transmitted along this line, clear, the wavelength is very short in comparison to the physical line. So that's why the phase, inductance and capacitance is also varied along the length of the line, or I can say the voltage at each point gets changes, clear. So that's why distributed parameters are used, and these distributed parameters cannot be represented by means of lumped parameters equivalently, clear. So these distributed parameters cannot be represented accurately by the means of lumped parameters, clear. Now see, this one, microwave transmission line therefore can be analyzed in terms of voltage, current and impedance only by the distributed circuit theory. Means this microwave transmission line, analysis of microwave transmission line can be expressed in terms of voltage, current or impedance only by the distributed circuit theory. Or I can say that when the very high frequency is traveling along the line, along the transmission line, at that time we always want to calculate the, I can only calculate the or concentrate on the field, means electric field and the magnetic field, and these electric field and magnetic field is somewhat related to the voltage and the current by the Maxwell equation. That's why I can say that this microwave transmission line can be analyzed in terms of the voltage, current and impedance only by the distributed circuit theory, clear. Now see, if spacing between the transmission line, if the spacing, let's say this one is the transmission line, this one spacing, if the spacing between the transmission line is smaller than the wavelength of transmitted signal, the transmission line must be analyzed as a waveguide. Means if the distance between these two conductors is very small as compared to the wavelength of transmitted signal, then the transmission line can be analyzed as a waveguide, clear. Now if I say the spacing between the lines, if I say, let's say if I say this is a D, if this D is greater than the wavelength, if D is very greater than the wavelength, then I can say the transmission line will radiate its energy into the space, means it cannot be act as a waveguide, clear. There will be a loss of signal, clear. Now for transmission line, when RF and or microwave signal transmitted through a conventional transmission line consisting of two open wires of length and conductors separation larger than the lambda, the energy is lost due to the EM radiation from the lines. I have already told you in the last slide that if the spacing between these is very greater than the wavelength, the energy is lost to the EM radiation from the lines. If I say this is a transmission line, if this space is D is very greater than the lambda, means the energy will be lost into the space, clear. So this radiation loss is reduced or eliminated by the transmission of RF or microwave signal through some guiding structure. So this radiation loss is reduced or eliminated by making the transmission of RF or microwave signal through some guiding structure, So this, considering the structure, this guiding structure may be consist of two concentric coaxial conductor, which is known as the coaxial lines, or I can say two parallel plate such as transmit or strip and microstrip lines, or I can say third one is the single hollow conductor called as waveguide. Clear? So this guiding structure may be of three types. First one is two concentric coaxial conductor called as coaxial line, like this one. Clear? Two parallel plates such as known as strip or microstrip line, means this one is act as a dielectric, and above there is a copper layer, and below which there is also a copper layer. One is grounded, another is of positive charge or at higher potential. I can say at higher potential. Clear? So this one is act as a microstrip line. Clear? In the strip line, there will be a conductor in between the dielectric. Clear? Or third one is your single hollow conductor known as the waveguide. Clear? Now the structure is further categorized into two types, or I can categorize into two types: multi-conductor line, that is examples are coaxial line, strip line, microstrip line, in which two parallel conductors are there, and the another one is the single conductor line, which is such as rectangular waveguide and the circular waveguide. Now see, for the transmission of signal through the multi-conductor lines or two parallel plate conductor lines, the field mode will be TEM or quasi-TEM mode. TEM mode is existed in the strip line, and quasi-TEM mode is existed in the microstrip line. Clear? So TEM mode is what? When E and H have only a single component and both are perpendicular to each other and also perpendicular to the direction of propagation. Clear? Now second structure, which is a waveguide, which is a one conductor line. In this, the mode can either be TE mode or TM mode. TE mode or TE or TM. TE is your transverse electric mode and TM is your transverse magnetic field mode. In the TE mode, what component of electric field will be perpendicular to the direction of propagation? Clear? And in TM mode, the component of magnetic field will be perpendicular to the direction of propagation. Clear? Now for the microwave signal, low frequency circuit analysis technique cannot be used. I have already told you, because the frequency is very high, in the microwave signal frequency is very high, so the analysis of high frequency circuits cannot be analyzed by the low frequency analysis circuit techniques. Clear? So therefore here distributed circuit or transmission line analyze should be used where voltage and current along a transmission line is vary in magnitude and phase as a function of position. I have told you that this one, I have already told you this one, that this one, microwave transmission line can be analyzed in terms of voltage, current and impedance only by the distributed circuit theory. And what is distributed circuit theory? In distributed circuit theory, you will see that if I say this is a transmission line and This one is also transmission line. Let's say input signal, here input signal having a low frequency, and this analysis of this line, of this line can be done by, or will be done by, the lumped circuit theory. In which you will see that if I say some voltage is applied, some voltage is applied that is V, that V will be same, that voltage will be same throughout this line. यहाँ पे भी same voltage will be applied, will be observed here, and same voltage will be observed here, and same voltage will be observed at the end, because this is a parallel. Clear? Now see here, if I say input signal frequency is high, when input signal frequency is high, this analysis of this signal, analysis of this transmission line can be done by the, or will be done by, the distributed circuit theory. Clear? Now see, in this if I say this voltage is applied at this point, let's say V1, so the voltage obtained at this point will be different from V2, and the voltage obtained at this point will also be different from V3. Voltage obtained at this point will be different from V4. Voltage obtained at this point will be different from V4 and all other. Clear? So I can say that or similarly for the current also. So I can say that distributed circuit theory analysis should be used where voltage current along a transmission of line is vary in magnitude and phase as a function of position. Means as a, if I see the voltage is varied is a function of what? Observation point. If I have observed here the voltage is different, if I have observed here voltage is different, observed here this, so means the voltage and current both are a function of what? Position. And similarly for the voltage and current, magnitude and phase both are a function of what? Position. So it means the here will be what? If I say this is a length line L, and if I say this is Z equal to 0 and this is Z equal to L, so here voltage will be what? Function of Z, and I will also be a function of Z. So this one is the distributed circuit theory and this one is the lumped circuit theory. And why this is distributed circuit theory? Because in this lumped characteristics, inductance and capacitance rule cannot be neglected at the high frequency. Now these are the figures which I have taken from the book. These are figures of the some transmission line. Let's say this one is the normal coaxial transmission line, normal transmission line. This one is the strip line, this one is the coaxial. Clear? And this one is the, if I say this one is what? Symbol of transmission line will be this one. Clear? Now we will discuss about the transmission line, theory of the transmission line, or I can say we will discuss here about the equation of the transmission line. Now see, if I say transmission line is an electrical signal propagating medium from transmitting to the receiving end, means transmission line is having an electrical signal which is in which electric signal medium which propagates the transmitting between the transmitting and the receiving end. Consider a two conductor uniform transmission line of length L is excited at Z equal to 0. So that means at the voltage, at the input voltage Vg of t will be equal to Vg of Z equal to j omega t, having a source impedance Zg and terminated impedance at Z equal to L by the load impedance. Clear? Now see this one. Now let's say this one is a transmission line and this was the input. Here the input is Vg of t, that is equal to Vg of Z equal to j omega t, and having a source impedance, means the source impedance is Zg. Clear? And load impedance is Zl. So V of Z comma t will be, means if I say in the time domain input signal V of Z comma t will be V of Z equal to j omega t, and in the time domain current will be I of Z comma t equal to I of Z e की power में j omega t. Now see this one. See this one. This is a transmission line. Let's say this one is the input signal having a voltage, and this is a generator having a voltage which is Vg, and this one is the impedance at the generator side, that is Zg, and this one is the load impedance at load, that is Zl. Clear? Now see, if I say this is a position at where, if I say this is a length L of total length of transmission line is L. Clear? So this one is the position Z equal to 0, and this may be the position of Z equal to L. So at, if I have all told you that the voltage and the current will be a function of what? Position, means at every point voltage and current will be different. It means if I say small part of the transmission line, let's say this one is known as delta Z, so here Z can be known as L minus D, and here Z will be what? Z plus में delta Z. Clear? So V of Z. Now see, if I say this is the input current which is incident, this is the incident current, and some current will be reflected back by the load, some voltage or current will be reflected back by the load, that will the reflected current. Or so this one is the incident current and this one will the reflected current. So overall at any point Z, किसी भी, if I say at any point of Z, let's say if I say this one position V of Z, if I say this is a position V of Z, at any point of the, at any point Z, total voltage and current on the line will be what? Superposition of what? Incident and the reflected voltage. Clear? And what is V of Z will be what? V of I equal minus gamma Z plus में V of R e की power में gamma Z. What is gamma? Gamma is the propagation constant, and e equal minus gamma Z represent that the direction of the signal will be in this direction from source to the receiving end, and VR is the reflected voltage, that is VR equal gamma Z, and this gamma Z plus gamma z represents the voltage is in the this direction from receiver to the source end. Similarly, I of z will be I of I इंसिडेंट करंट यो माइनस गामा जेड प्लस में आई ऑफ आर ई की पावर में गामा जेड. So these are the mainly basic transmission line equation, and in the next lecture we will discuss about the solution of the we'll derive the transmission line equation, clear, and also we will find out the solution of the transmission line. So this one is the solution of the transmission line. In the next lecture we will discuss about the what is the transmission line equation. The book I have referred for preparing the slide, that is Microwave Devices and Circuits by SM Leo, that is the 3rd edition. Thank you.